visualize an equation. So let's say that we had y minus 3 equals negative 1/2 times x plus 2. And we want to find the intercepts for that line, x-intercept and y-intercept. So x-intercept is a place that it crosses the x-axis. If a point is on the x-axis, that means that the y-coordinate is 0. Because if the y-coordinate is not 0, then it's above or below the x-axis. So the x-coordinate, or the x-intercept, will have a y-coordinate of 0. So you're just going to plug that 0 in for the y value in your equation. And then you're going to solve for x from there. Okay, so usually you guys are good with this side. 0 minus 3 is negative 3. And then we have a couple of options for how to solve and get x alone based on what's on the right side of the equation. So what do you guys want to do next if you're trying to solve for x here? Right? Okay, so one option is to just distribute the negative 1/2. So you have negative 1/2 x. Then you also have to multiply negative 1/2 times positive 2, which turns out to be negative 1. And then you would do the normal things that you do here to get x alone. So we would add 1 to cancel that out from both sides. And then at this point, you would want to divide by negative 1/2. That's the same as multiplying by the reciprocal. So sometimes when we're dealing with fractions, you might want to look at it this way instead of the dividing by 1/2, because you guys tend to write that, but then you kind of don't know what to do next. So it seems like this might benefit you. And so then I'm going to get that x is equal to 4. Okay? So this line would have an x-intercept at 4, 0. If I graphed it, I should see it cross there. Is that okay? The little negative, sorry. Okay. All right, now to find the y-intercept, same exact process except for plugging in 0 for x. So we're going to have y minus 3 equals negative 1/2 and then 0 plus 2. The y-intercept sometimes is a little bit simpler for you guys, not because the y-intercept is easier than the x-intercept. But we write everything with like y equals, and we put most of the stuff on the other side. So when you're finding the y, everything is almost on the other side already. So it's very little work to get y alone, but x usually has a lot of stuff surrounding it, so it takes a little more work. So here, this is negative 1/2 times 2. And negative 1/2 times 2 is negative 1. And then we would add 3 to both sides. So we get that y is equal to 2. So our y-intercept is at the point 0, 2. So basic idea, this is from linear equations. So we didn't have to do anything fancy, taking square roots, squaring, anything like that. Okay? So the other functions that we did, just to keep track for you guys. So we did linear functions. With our linear functions, we also did piecewise functions. So if you're looking for a list of things that will show up on your test, this would be stuff. We did piecewise functions. Then we did linear functions. Then with transformations, we did quadratics, cubics, square roots, and cube roots. Okay? So these, you can expect questions like showed up on your quiz, and you'll get those back, where you should be able to list the transformations, make a table, make a graph, vertex, domain, and range. And now you should be able to find the intercepts as well. Okay? That's a focus that we're going to have. So as far as where it is in your note guide, if you don't have the note guide, you are just going to, in your finding intercepts notes that you're taking right now, add the next section that's for a quadratic. If you do have the note guide, you're going to have to flip a few pages, because remember what we did. After the linear stuff, we did the quadratic and the cubic parents, and then examples of them. And the place for both of these intercepts is on the page where the problems were for the quadratics and for the cubics. Okay? So this is the quadratic that we graphed. And now we're going to try to find x and y intercepts. Okay? So for x intercepts, we're plugging 0 in for y. And so we had probably a little simpler than this, but a problem similar to this in the weekly review a couple of times to kind of prepare us for this. So what do we want to do here to solve for x? Luke? Okay, so we have, I heard distribute and FOIL. So one option is you guys could FOIL this and then distribute the 2, subtract the 4, and then you could try to factor it or use the quadratic formula to solve it, okay? But because it's written the way it is, where everything's kind of nicely packaged, all your x's are inside of this perfect square, we don't have to do all of that work. That's a little bit longer than what we can do. What could we do here instead of foiling it, distributing it, and then using the quadratic formula? Good. We can square root it once we get the perfect square part alone. So we're going to add 4 to both sides. Good job, Trevor. And I'm going to go ahead and divide by 2. So my purpose in doing that is I don't have x alone, but I have the one thing that contains all my x's alone, and now I'm going to work on doing whatever operation undoes that one that is there. So what's here is a square, so I'm going to go ahead and square root both sides. And what do I have to remember if I am applying this square root to both sides? So you guys did this in the weekly review, and almost everybody got it wrong because they got one solution, but they didn't get the other solution they were supposed to get when they square root both sides, plus or minus, okay? So this isn't just rad 2, it's positive and negative rad 2. There's 2 options there, okay? And then the last thing I would do to get x alone is add 5. Now, without a calculator, I don't expect you to calculate this as a decimal, but I expect you to be able to write it properly, which means I would say at this point that x is equal to, I have a positive 5 here, and it's being both added and subtracted with rad 2. Like rad 2 has both a positive and a negative sign. That's 2 solutions. Okay? So there are 2 x-intercepts for this graph. It crosses at 5 plus rad 2, comma 0, and also 5 minus rad 2. Which means if you were looking at a graph of this function, which we did earlier and is on like your page prior to this, you should see it crossing at these places. And you might be like, I wouldn't even know what those places are. But, okay, rad 2. It's bigger than rad 1, and I know rad 1. The square root of 1 is 1. Rad 2 is a little bit more than that. So say I call it 1.1 or 1.2, something like that. 5 plus 1.2 would be 6.2. 5 minus 1.2 would be like 3.8. I should see my things cross around those areas, okay? This is going to help you on the test if you think something went wrong with one thing versus another. If everything's connecting and making sense, then you'll have more confidence in what you're doing. For the y-intercept, we're going to plug 0 in for x. And again, as long as we follow order of operations here, the y-intercept is a little bit simpler just because of the way we write it. See, y is already by itself, so all I have to do is get through this calculation and I have the y-intercept. Okay? So inside of grouping symbols or parentheses first, so this is negative 5. And then exponents before you multiply, so negative 5 squared is 25. And then multiplication and division before addition and subtraction. So we're going to have 50 minus 4 is 46. Now you might not see where 46 is on your graph, but the way this parabola is drawn should make sense that 46 could be the y-intercept, meaning you see it, you don't see it cross the y-axis, but it makes sense it would be way up at 46. Now, the parabola can have 2 x-intercepts. So some of you guys, another helpful hint for studying for your test, kind of a basic idea, some of you on the cubic quiz were graphing cube root function. So you really should connect shape to what it is. So we were graphing this on the quiz, but some of you were drawing this. Okay, and I get it. Their names are almost the same. They both have that index of 3, cubic, cube root, but we have to be able to differentiate them. Also, the visual gives us some good ideas of what's going on. We just found a quadratic that has 2 x-intercepts. Is it possible that a quadratic, a parabola like this, could cross an x-axis 2 times? Yeah, okay. Can anything else up here cross the x-axis 2 times? We'll say linear is like this. Okay. The cubic could if it wasn't one that we studied with transformations. If it was one where we had like that, but that doesn't work with our transformations. So if we're only graphing them from transformations, this is the only one that's going to cross the x-axis twice, because it's the only one that turns all the way around. Okay? linear functions, if they have a slope, will cross the x-axis once and the y-axis once. Quadratics can only cross the y-axis once. Remember how they passed the vertical line test? They don't have more than 1 point on any vertical line. So it's going to cross the y-axis 1 time. Cubic will cross the y-axis 1 time and the x-axis 1 time. Same with cube root. Okay. What about square root? Could it cross the y-axis more than 1 time? No. Okay. Can it cross the x-axis more than 1 time? It looks like it's almost horizontal, but it's technically still growing the whole time. So it might stay really close to it, but it'll only cross through it at one exact point. Is it possible that it doesn't cross the x-axis at all? It doesn't cross the y-axis at all? Yeah. So this one's going to have some special things we're going to have to pay attention to with our algebra. But then also the quadratic. Is it possible the quadratic doesn't pass the x-axis at all? Yeah, what if the x-axis was down here? And the whole thing was above it. So there is something we have to pay attention that didn't happen here but could happen in the future. When you guys take what could have happened in this problem if the numbers were slightly different, that we would have stopped and said no solution or no x-intercepts instead of being able to get these two numbers that we calculated. What could have happened in this process where you would have been stuck at a point where you could not do the calculation? Not like not in your head, but even a calculator couldn't do it. Good. Did you guys hear Koi said, what if there was a 2 under, like the 2 is negative? Then when you went to take the square root, you can't get a real number here anymore, right? Which means it's not going to be something on the graph. So when you guys are square rooting a negative, you're not going to have any x-intercepts. Okay? If you get to that point, you could write them as imaginary numbers or complex numbers if you want, but you don't have to. If you're trying to find places that it crosses the x-axis, square root of a negative doesn't exist as a real number because it doesn't cross the x-axis. You won't see it happen on the graph. So if you come across that situation, you would stop there and you would just say no x-intercepts. There aren't any. And that should match the information on your graph. Okay? Is this okay with everybody? What could happen here and what we have to be aware of in this situation? Okay? It's just these two situations that are going to be difficult because they're the two that have some different circumstances besides for sure have one of each intercept. Okay? Here's the cubic that we graphed. So if you're taking notes on your own paper, okay, these are intercepts for the cubic. I'm going to approach this the same way we approached the quadratic. The only difference is that there's a cube. So when I go to take the square root, I wouldn't take the square root. I would take the cube root to cancel out the cube, which is actually easier in one sense. There's nothing to worry about, oh, I can't cube root negatives and all this. It doesn't matter. Cube root of negative 8 is negative 2. Negative 2 cubed is negative 8. Okay? Cube roots and cubes keep their signs the same so that we don't have to change them. So here I'm going to do exactly what we did last time and try and get that portion that has x in it by itself. I'm even going to divide by this negative if I just want to make it more clear what's happening. And then right here, once I have that cubed part alone, I'm going to take the cube root of both sides. So cube root here so that I cancel out that power and just have x plus 6. And cube root here. So the cube root of a negative is negative. I'm not a calculator, so I don't know what the cube root of 4 is, and that's okay. I would keep it there. If it was asking me the cube root of 8, I would know that was 2, and I would obviously write it the simpler way. This is where we're at. Now notice, no plus or minus. I don't have to include plus or minus because a negative number when it's cubed is negative. A positive number when it's cubed is positive. These are actually easier to deal with in that sense. Okay, there's no craziness about was it positive or was it negative. And then we're going to subtract 6 from both sides. And again, I don't expect you to know what this is because you're not a human calculator, but you just need to write it correctly. There's a 6 that's negative being added with a cube root of 4 that's negative. So in any order, you can write those, but they should have the appropriate sign with them. So you could write negative cube root of 4 minus 6, okay, if you want it. Or like I have it, negative 6 minus the cube root of 4. So that would be your point. Okay. And then again, we do the y-intercept with the same type of work, just plugging in 0 for x. And again, because of the way we've written it, if you can get through order of operations, you should be able to get through this process. So this is a negative, this is a 6 that's being cubed. That makes this negative 216. So negative 220. So when we're solving a cubic or a quadratic, if we want to get x out from underneath the cube or the quadratic, we use radicals. With square roots, we need to be careful. With cube roots, it's all going to work out just exactly whatever signs are already in there. Okay? Any questions about the square root or the cube root, x and y intercepts? Okay, so then the last thing we have to do are the roots. So square root and cube root, okay? So same thing, we did parents, then we did examples, and then on the page where the problems were is the place where the intercepts are. And just like we were just talking about, since the quadratic and the square root are a little bit unique, like they might not cross an axis, those are the ones we have to be more careful with our calculations because they're the places that something algebraic might not work out. So here, when we go for the square root to find the x-intercept, so we set y equal to 0, we're going to use the same idea as we did before. We want this part alone, this whole thing that's underneath the radical, because that contains x. So we're going to add 3 to both sides first. And what am I going to do in this case now? So x is trapped underneath a radical, and I need to get to a place where I can just say x equals this. Square it, okay? Because squaring will undo the radical. So I'm going to go ahead and square both sides. And then I'm going to finish solving for x like I normally would. So we'll subtract this 5. 4 equals negative x. Divide both sides by negative 1 and get that x is equal to negative 4. Now, I want you guys to make a note for these ones. You should check. Just like the quadratic, either you need to check your work or you might come across something that doesn't actually make sense. Okay? In this case, it works. Look, I'll check. If I plug negative 4 into the right side, do I actually get 0? So negative 4 with a negative in front of it would become positive 4. Plus 5 would be 9. The square root of 9 is 3, and 3 minus 3 is 0. Totally works. This one's fine. However, look at how this works when you have things under a square root. Let's say I had the square root of x plus 1 equals 2, and the square root of x plus 1 equals negative 2. So you would solve both of these problems the same way, right? Square both sides. And so this one becomes x plus 1 equals 4. And when you square both sides of this one, it becomes x plus 1 equals 4. They are now the same problem, and they have the same solution. But were they the same problem when we started? No. 3 is only the answer for which one of these? The top one or the bottom one? Which one, if you plug 3 back in on the left side and do the calculation, you actually get the number you started with on the right side? The top one, okay? 3 plus 1 is 4. The square root of 4 is 2. This one's wrong. We didn't do anything wrong. But it's wrong. It doesn't work. Okay? Here's why it didn't work. Right at the beginning of the problem, we had the square root of something equal to a negative value. You're never going to have the square root of something equal to the negative value unless there's a negative in front of the square root to make it negative. Okay? So you have two choices. Either you always solve over here, but at the end you better plug it back in and check. Or you watch out for this. Okay? If you ever come across a square root equal to a negative value, okay, that's not possible. And at that point, instead of keep going and square and all of this and get something that doesn't work when you plug it back in, you could just stop and say no x-intercepts. It's not going to work, okay? So again, remember, it's these two situations, the quadratic and the square root, that have shapes where they may or may not cross the x-axis, where you have these problems that you could come across with the algebra. Okay? So the y-intercept, a little more straightforward. Okay? You just plug in 0 for x. And here we would have rad 5 minus 3, and that would be the best we could do. Because we're not putting it into a calculator. When would you get that this had no y-intercept? Because we said this could have no y-intercept. When would you plug in 0 for x and you wouldn't be able to calculate an answer? What would happen in a square root function that you wouldn't be able to calculate the answer? A negative under the square root, okay? And then it wouldn't work. So if I plugged this negative in here and it had just been like negative 3 or something, I would have stopped and said no y-intercepts. Yeah. So this is not plus or minus. So every radical is not calculated as plus or minus. So if I walk up to you and say, what's the square root of 4? The answer is just 2. It's when we have something squared equals 4, like x squared equals 4, you don't know if x was 2 or negative 2. So if you put the square roots on both sides of the equations to solve it, we include the plus because there's like an element of unknown there, and either one could have worked. But when it's a square root that's already there, you just calculate it as it is. Okay? All right, so the last one is the cube root function. And again, you might not like cube roots as much as you like square roots because the index is 3, but they're a lot easier as far as checking and stuff like that to make sure something works. It always works, okay? So our x-intercept, we put 0 in for y. And then just like before, I want to isolate this part that contains x, the part that has the radical. So I'm going to subtract 6. And divide by 2. And I'm going to have a negative number equal to a radical. And if this was a square root, I would stop right there and say not possible. There's no way that this square root made this negative value. But it's a cube root. As long as the number in here was negative, when I took the cube root, I would get a negative value too. So that's perfectly fine. I don't have to worry about it when I'm dealing with cubes and cube roots. So I'm going to get negative 27 equals x plus 2. Okay? And so then x is equal to negative 29. So my x-intercept will be at negative 29, 0. Okay? And then the y-intercept, plug in 0 for x. I do not expect you to know the cube root of 2. Again, I just expect you to be able to write it. So this is as simple as we can get. So the y-intercept is 0, whatever this number is.